Okay, so I'm Aaron Krauss. I am a developer. I don't do Ruby as often as I would like to, honestly, but I do it quite a bit, and I have done it pretty extensively in my history. Metaprogramming is something that Ruby is really good at. Really, any dynamically typed language is going to be better than a statically typed language. We're not going to dig into what those two means. Those two phrases are, you can Google them. But Ruby especially has got some really cool capabilities. Now, before we dig into that, I'm going to brag about the company I work for. So I work for a company called Clever, as well as a handful of those of us in the room as well. We have a new logo. We just did a new rebranding like last week or the week before. So this is our Clever Fox. See? The Clever Fox. But you're going to start seeing that everywhere. So what does Clever do? Clever is a software consulting company. You've probably heard me talk about it before. We work with local clients to help them make money, and they pay us. That's consulting. We work with software applications, mobile applications, DevOps, virtual reality, games, anything literally software related. We've gotten into some hardware stuff too. So literally anything technological, please hit me up, hit up anyone that works there. And we are looking for developers. So, and again, like Ruby developers as well. So if you want a job, feel free to hit me up at Clever. We are hiring like crazy. We're growing. It's awesome. Yeah, hit me up if you are looking for a job. So that's what Clever is, and I'm a software engineer there. So before we get to the actual talk, I do want to talk about the future of this group. We've mentioned this at some of the meetups before, but this group is going to be, OKC Ruby is going to be transitioning at the end of this year. Beginning of next year, 2020, January, we're going to be merging with two other user groups, the JavaScript user group and the Python user group, and we're going to form a new group that's tentatively, but I'm pretty sure we're going to land with this, called OKC Web Devs. The idea is a lot of our technologies overlap, and it's, I think, to take all of our groups to the next level, we want to combine the technologies to be more of a paradigm and not really Ruby or Python or JavaScript, because there are a lot of topics that extend to all of those, and honestly, if this does not mean that Ruby is going away. That's absolutely not it. It just means that if you have a talk with Ruby, well, one thing it means that John and I are going to have to struggle as hard to find Ruby speakers, because we know not everybody does Ruby, but if you have anything JavaScript or Python or Ruby related, or really anything web dev related, we're going to remain active user groups of this new user group. We're planning to meet on the date that JavaScript currently meets, which is the third Tuesday of every month. That's still tentative, but that's the plan right now. The reason being is that JavaScript has historically had the largest community, and they're the oldest user group of our three. But that's the plan. So everything stays the same throughout the end of this year. We're still going to be OKC Ruby through December. But the beginning of next year, January 2020, we will merge with the other user groups to become OKC Web Devs. So you'll probably start seeing that on Meetup over the next few months, but that's the plan. Now, we can actually talk about some real stuff. So what's metaprogramming? Well, it's a lot of things, but the closest thing that you might have heard of before is maybe the term metadata, which is data about data, is kind of the closest definition of that. So does that mean that metaprogramming is data about programming? Is it programming about programming? And my answer is yes to all of that. Metaprogramming is code that writes code for you. And that probably just sounds crazy vague. And you might also be thinking, isn't that what code generators do, like the Rails gem or Yeoman or Slush or really any code generation tool that you write, or even a bytecode compiler? And the answer is yes, but metaprogramming usually refers to something different in most languages, especially Ruby. So, and this is just kind of fun fact, I used to blog quite a bit heavily, and I was Wikipediaing some things about metaprogramming, and I'm on the Wikipedia references page. That's pretty dope. I was just searching literally for the word reflection, and I was like, oh, there's a citation there. I just wanted to share that. So, talking about metaprogramming in Ruby. So, in Ruby, it refers to writing code dynamically at runtime. It's not code that you write statically. Ruby is a dynamically typed language, so it gets evaluated at runtime anyway. What I mean here is that it's not code that you are writing beforehand statically. And if any of this is not making sense, that's okay, because we're going to dig into this. This is an advanced topic. Not only do you have to know some Ruby, I think you'll be able to get by if you don't know Ruby, that's okay, but the concepts are not going to be the easiest things. So brace yourselves, we're diving deep in. So some examples of metaprogramming just across languages are type introspection and reflection. Type introspection is where you ask questions about an object specifically or a data type. What type of data is this? Is it a class of this? Is it a class of that? Is it a subclass of this? All those questions are type introspection. You're just asking questions. You're just getting data. You're not doing anything with it. Reflection is where you take type introspection to the next level. It's where you invoke methods at runtime, and we're going to see that here. Using a string, like a variable, if you want to, you can invoke a method that way. You can instantiate an object at runtime. Again, not the traditional way. But reflection, the idea is you're actually mutating the state of the current application at runtime. We're going to dig into all that. So with metaprogramming, there's a big theme here. It's going to be very powerful. We're going to be able to do like some crazy cool stuff, but it's also pretty dangerous. And there's two reasons as to why it's dangerous. Let's see if I list those out here. Anyway, before we get to that, Uncle Ben in Spider-Man says, with great power comes great responsibility. He's talking about metaprogramming, not anything else. I don't know what else happened in that movie, but he was really only talking about metaprogramming. But with metaprogramming, there's two kind of dangers there. One is your code can get rapidly complex, and it can do some really cool things in a very short amount of lines of code, but is developer 2 going to be able to read that? How about developer 3? What about junior dev 1? Those are the questions you need to ask. And the other question is, when you get into metaprogramming, the whole point is to be able to bend the state of your application at your will, and that can get pretty messy too. You could be you have the power to, for example, modify private variables outside of any scope that you would reasonably expect to do that. You can evaluate, whatever code you want to at runtime. There's dangers there. We're gonna get into all that, but at the very least, I want this to showcase the power that you can do with metaprogramming, especially with how you can do it in Ruby. So let's get started. So let's say, hypothetically, you want to create a method that'll accept a string and strip out everything except for alphanumeric characters. So we build a little function like this. And by the way, we are going to be evaluating code right here. We'll talk about the tool I'm using for this afterwards. But to do that, you're going to see me wipe out that line that says capture all the time. That just hides the output. So to do that, we just create a function. We pass in a string. We're going to gsub out everything that's not a word or a character or a space. Look at this really cool, I don't know how that got there, just a really cool line of code there, string there, and it says Aaron is the boss. Plain and simple. But it's not very object-oriented, and Ruby is an object-oriented language, so let's rewrite this a little bit. So what we can do in Ruby, you have the ability to just bust open any class you want to at any point in time. Other languages have this idea too of partial classes. Ruby calls them open classes. There's no limit to how often you can do this. So what we can do is we can actually just, at any point in time on our code, we can enter the string class, which is a top-level class in Ruby. It's a default Ruby class. We can define a function in there called toAlphanumeric. By default, it's going to get invoked on our self, which is going to be the object we call it on. And we're just going to call that same function gsub, subbing out everything, all words and spaces with nothing right there. So we can call our string, which is an object. In Ruby, you'll hear the phrase, everything is an object, and that's very true. Not everything, though. It's mostly true, I should say. But in this case, a string is an object. So we can just call, and it's an object of type string, even though we didn't have to instantiate it in any fancy way. And we just call toAlphanumeric on it. So let me get rid of that. And bam, it works the same way. And we're doing it more object-oriented, more of an object-oriented approach. None of this is really metaprogramming, but except for this idea of an open class, we can modify any class at any point in time, bend it to our will. This is just the beginning, though. So that's cool. There's a problem, though, with this. Let's say we wanted to modify the array class and create a function in there called replace that all it does is we give it two arguments. One of them is the item that we want to replace, and the other item is what we want to replace it with. So let's do that. Again, array is just a default Ruby class. We didn't have to define it. It already existed. This is of type array, an object of type array. Whenever we run that, so we had an array called xyz. We just replaced x with a per our new function here, and it works. So what's the problem here? Well, the problem is that there actually was a replace method already on the array class that we just completely overwrote. And what that function did is it, instead of passing in two arguments like we are right now, we pass in an array, and it just replaces the entire array. It's an interesting function, I'm not going to lie, but it is what it is. Like it existed before, and we just completely overwrote it. We can't access the old function at all. And we didn't get any error for this. Like we just changed it, and that was it. So this might work for code that you're writing in one place of your project, but if someone else is depending on the old array replace function, well, then you've just really messed them up. And it's not like this is a clear error message that they're not gonna say like, oh, Aaron just messed with your function. Like, it's gonna be a very unclear error message. So what can we do about this? First of all, this process is called monkey patching. That's not a Ruby specific term, that's just a term for this. It's not bad, it really isn't, but you just need to be aware of what you're doing. And I think that kind of defines metaprogramming in general. Just know what you're getting yourself into. Powerful, but there's a responsibility you have. So with open classes, in Ruby, one of the slightly newer things you can do to protect yourself against this, and I say slightly newer because it's not that new. Back in 2010 with Ruby 2.0, they added refinements, and I think not enough developers know how these work, but this is a way to protect yourself against specifically this idea where you're modifying an open class with a function and you are worried about overriding something. This is how we can protect ourselves against this. So refinements add 2 new keywords to Ruby, specifically in the module class, called refine and using. Why did they do it in the module class? We'll dig into that right now. So what we can do here is to rewrite what we just did. We can use a refinement, and what this will do is it kind of scopes out that function for us that we can, if we want to use our refinement, our refined class, our refined open class, we can specifically say that we want to use this refinement. So what we do, we're inside of a module. Modules in Ruby, you just don't instantiate them, you include them. They're basically just a collection of methods. If you're familiar with the idea of a mixin, that's why you would oftentimes use modules in Ruby. So we're inside of a module, we're just calling it replace me. We're using that keyword refine that we can access inside of a module we're saying refine array, which is a class name. It accepts a block. If you're not familiar with how blocks work, there's a cool talk that I may have given about that. It's on YouTube. Anyway, we're going to refine. Everything else is the same here. We're putting in the function. We're replacing our replace function. Everything is fine here. And then whenever we have this first line here, puts, just the print statement in Ruby, whenever we replace, we're using the old version of replace because we have not said anything about using this refinement yet. We're replacing it with this array, and it's going to work as we expect. Now, from this point on, we're going to say using replace me. That's our refinement. So whenever we say using, it accepts a module, and then it will specifically look for any refinements in there and run them. And then we can use our refine method here. So if I delete this line, and I just put a blank line statement in there for put so you can see the difference. But you can see the first function is the original replace method. We just replace the array with an entirely new array. That's y. Next function, next replace function uses our refined replace function. And it runs how we expected it to be, just replace x with a. So if you do have to do open classes and you're concerned about this, then use a refinement. If you are creating a very specific function that's named a little bit better than replace, let's say, then you may not have to use a refinement. It's up to you. But here's a way to actually protect yourself against this cool metaprogramming idea. Later on, there's less protections. You just have to know what you're doing. Okay. Before we get deeper, and I think this is going to be incredibly valuable, just not only to understanding Ruby, but understanding how different languages handle things architectural-wise, we need to talk about Ruby's object model. And this is going to be a kind of convoluted picture, but we're going to take it step by step. I'll zoom in a smidge. So a lot of this we're not going to focus on, but we're going to focus on, let's focus on this part right here. And this is what you're going to be pretty used to in object-oriented programming. We have 3 objects, object 1, 2, and 3, and they are all objects of class my class. That's just object-oriented programming, nothing new there. Now, where we go from here, in Ruby, any class that you define inherits from a class called object. And we'll learn more about that in a little bit. But this is inheritance right here. So my class, just by default, is always going to inherit from object. You don't have to specify that. It just gets everything from object. However, this comes back to the idea that everything in Ruby is an object. That is true for classes. Classes are actually objects in Ruby. They're also classes. Head explosion, I know. But my class is a class. It's called my class, but it is actually an object of a class, wait for it, called class. So we're going to be using the word class quite a bit here. So just to review that one more time, my class has 3 objects called object 1, 2, 3. It inherits from a class called object, but every class in Ruby is actually an object of a class called class, at least somewhere down the chain. And this just, I'm honestly not sure how this little loop here works. Like apparently class also has a class of class. That's probably not architectural wise, that's probably just what the class function returns. If you ask what class is class, I told you we were gonna use that word a lot here. And this part's not really important. Class inherits from a class called module. Module inherits from object, and object has a class of class. That's not really important here. I just wanted to focus on this line here and this line here. I know, it gets crazy, but this is important to know because as we get deeper down in some of these metaprogramming topics, we use these relations here. So just to review some of the key things here, instantiated objects have a class of my class. We talked about that. That's just this area here. My class has a class of class, which is also an object, which is right here. And then while it has a class of class, it inherits from object. Just some key things to note here, and this is pretty standardized in Ruby. So that's Ruby's object model, and I know, again, may not make a ton of sense right now. You might think it's odd, but that allows us to do some cool things down the road. Now, the next thing I want to talk about is the ancestors chain, and after this, we're going to jump right back into metaprogramming. This one's a little bit easier to understand. When you call a method in Ruby, Ruby goes right into the class of that object and says, what do I have access to? Do I have this function? If it does have the function in that class, we invoke it. If it doesn't, it's not going to immediately throw an error. It's going to say, okay, do any of my inherited classes have that? Or do any of my included modules have that? And if it goes all the way up the chain, up all the way through inheritance, if it can't find it, then it's going to throw an error. But the way that would work here, we've got an object B, and that's of class book. The shading things here indicate an included module. Everything like object and basic object are still classes. So book has two modules called document and printable. However, book inherits from object. Object has a module called kernel included, and object inherits from basic object. This is actually the very tip of the inheritance hierarchy in Ruby. So basic object is as high as you can go. And then object inherits from a basic object. I actually don't think anything else inherits from basic object. I'm not positive of that, but you really don't talk about basic object much in Ruby. If you were talking about like a top level thing, usually you just refer to the class called object. But let's say you call a function foo on B. It's going to look in book. If it's not there, it's going to look in each of the modules that are included in book. If it's not there, it's going to look in object, etc., all the way up. And again, if we can't find anything, then it just throws an error. This right here is not necessarily, this is not metaprogramming, these topics here. This is just how Ruby works under the hood, but it's very important to understand this so that we can dig back into how and why you would use certain metaprogramming tools. So back to metaprogramming, we're going to talk about how you can just do all kinds of fun stuff with methods or functions, whatever you want to call them. In Ruby, you can create methods. It's an object-oriented program, but I mean that doesn't mean you have to have methods. But instance methods are object-oriented. But you can dynamically create them as well, in addition to how you would normally create them. We're going to talk about both of those. You can call methods that don't even exist either, which one could throw an error, but it doesn't have to. We're going to get to that here in a second. So there's three parts to this piece, to methods. So we're going to talk about dynamically defining a method first. Why would you want to dynamically define methods? You can reduce code duplication, you can add cool functionality, you can make your friends say, wow, I didn't know you could do that. But let's talk about like active record, for example. And this active record kind of set the stage for a lot of ORMs, like Eloquent, like what we're using quite a bit at Clever. So active record, for example, if you've used it before, this probably looks familiar. You have a model that is an active record model. It inherits from an active record base here. And we can just assume that relates to a database table called book. We're going to instantiate an object of it, and we're going to call title. Well, if I run this code, it's going to fail right here. But if we if we see this in production, we would assume it really wouldn't fail. We would just assume that there's a column in the book database table that's called title. Well, even though in the model there's no actual function called title, we didn't have to define anything. Active record behind the scenes created the method title at runtime by looking at the database table. I'm not sure how it does that. I don't know if it looks at the schema files or what, but it does it behind the scenes dynamically. There's no actual space in the code that says there's an attribute accessor called title, which that's another thing. We're not going to dig into that, but when you see attribute accessor, attribute reader, attribute writer, that's actually metaprogramming in Ruby. Those methods are getting defined. Those getters and setters are getting defined on the fly. You're not the one defining them. You're just saying create these functions. So that's kind of the very simple metaprogramming you can do. But this is dynamic method creation, and we're not the one creating it, but it is happening here. So this is an idea of where metaprogramming might come into play. You might Like if you use active record, you would probably hate to see all the code for all the getters and setters that you have to do, but you don't have to do them. So how can you actually do that yourself? Well, we've got three functions here, foo, baz, and bar. They're standard functions in Ruby. We invoke them, just like foo, baz, and bar. We call them. It's nothing special. It's pretty simple there. Well, they're all pretty similar too. They just say blank was called. They say foo was called, baz was called, bar was called, and they're just the same name of the function. Well, what if we can use some sort of looping structure to create methods that did this without all that code right there? And not that this is a lot of code, but the proof of concept is coming. A lot of duplication there. Well, what if we could write something like this, and this is where we're getting into that metaprogramming idea of it being a little bit harder to see what's going on, but it's powerful. If you're unfamiliar, this is just this quick way to define an array in Ruby. I say quick, I mean it's already quick in general, but this is just another way to do it, just the %W. There's other little asterisks or other percentage sign keywords, and I think Austin actually gave a good talk about this in the past too, so if you want to learn more about that, look at Austin's talk on YouTube. But we're iterating through strings. This is an array of strings is what the W means. Foo, baz, and bar, and we're calling this function called define method, and we're passing in whatever the actual string is, and then we're saying do, it accepts a block, and we're saying puts, function name was called. This is actually us defining methods at runtime without the traditional way of doing it in Ruby. We can just define them as at will.
So,
and this will allow
my name is
like
Austin Keaton.
Scope outside
I
the
work at LegalShield as a web developer. We provide
all in all, we didn't save a ton of code
basically
here, but
subscription-based legal insurance.
Some of the powers that you can do
we are an Oklahoma-based company. Our headquarters,
as far as metaprogramming goes. So define method is defined in the module class. Module class, every that's somewhere in that Ruby's object model. Class inherits from modules. That's why we get access to that. So you can see, I say you can see how much code we saved, especially if we were writing real methods. This one is obviously not saving a ton of code here, but this is something that, no internet apparently. Well, actually, we'll come back to that at the end. I have a little real life example of where I use define method to save some code, so we'll come back to that at the end if we have time. I think I know the password, but. So is it worth the complexity? That's your call, and it's gonna get deeper than this. We're gonna get much more complex here. Methods, part 2, dynamically calling the methods. So we just created the methods like that. How do we call them? Well, you saw how we called them here, like normally. These are just normal. It's not statically called, but that's what I'm going to refer to them. They're just called the normal way in Ruby. We're not dynamically calling them. To dynamically call them here, again, this is going to be a very similar function here. We just swapped out the array here. We're going to iterate through them, and we're going to use this function called send. We're going to talk about where that comes from. But here, we're actually, and this is reflection. This is full-blown reflection right here. Defining methods is actually reflection too. But we're actually mutating the state of our current application dynamically. What send does, is it's actually going to invoke whatever constant this resolves to. So test n, that's going to be test 1 through 5. We actually have functions like that here, and that's going to run those functions. So if you ever need to run a function by a string, for example, you would use send, and this is a perfect example of reflection here. And you'll see it's pretty easy to do this stuff in Ruby. If you need to do this stuff in JavaScript or PHP, it's pretty easy too. And really in any dynamically typed language, it's pretty easy syntactically to do this. Where you get into the difficulties are maybe in Java or C#. It's a little bit more verbose to do this, but you can do it. It's just easier in a dynamically typed language. You can see though, all the calls were invoked for all those 5 functions. We just iterated through them, and we just invoked them off of a string right here. This is probably one of the most common use cases of reflection, invoking a function at runtime via a string. So this is dynamically calling methods part 2. So send is defined in the object class, which all user-defined classes inherit from, which is why we can do them at runtime. That's why we have access to it here. And then because we're merging with Python as well, I wanted to give a shout out to Python. We can also send, you don't have to invoke it in the global scope, you can invoke it on an object as well, again, because object has it and all classes inherit from object, and objects are instantiated out of classes, so you have access to it. So if we run this, you can say, let me invoke this function on OKC Python. So we're just invoking it based off of a string, and it evaluates to true there. Now, The power here comes when you want to call a method based on some in-scope situation, oftentimes based off of a variable value. We're going to talk about that a little bit later. Send will allow you to also call private functions and private instance variables. You may not want that, so if you know for a fact you don't want that, you can use public send as well. You have access to it in the same scope that you would send, so that'll just limit you to having access to public things. The last part, ghost methods. This is a pretty cool feature that Ruby does. I've not seen other languages do this. I'm sure you could hack a way to do it, but it's cool. It's also dangerous at the same time, but it's a unique thing. So ghost methods in Ruby, if I were to do this, and again, I've got this class here called book. It is not an active record class, so there's no special metaprogramming that active record is adding on. We're instantiating an object and we're calling book.read. If I try to do this, it's going to throw an error. It can't find a read on it. That's expected. But it threw a no method error. That's important. If we, let me just make that so it doesn't throw an error. There's it. We get an error, but it doesn't have to be that way. What we can do, we can use what are called ghost methods. These were used quite a bit in Ruby, especially when it comes to active record. It's not used as often anymore. We're going to talk about why that is. But what are ghost methods? So in Ruby, there's this method, this function called method missing, and it's a Ruby defined thing. You don't have to, by default, there is a method missing all the way up the chain, and the default action, if you call a method that doesn't exist, it's going to call this function automatically, and the default behavior is just to throw a no method error. That's why we got that no method error. You can actually intercept that wherever you want to, and again, because of the ancestor chain, it'll just go up the chain. So if you get a no method error, if you try to call a method that will throw a no method error, if you have this function, it will try to look at that first before it goes higher up the chain. And by default, method missing will always get these three items here. It'll get the method name you're trying to call. It'll get any argument you tried to pass. And if it accepted a block, then it'll give you your block. We'll talk more about blocks a little bit later. But for example, right here, we have the same class. We just put this method missing in there. We're just printing out you called method and args join. Don't worry about the syntax highlighting. That's your editor would actually highlight that correctly. Mine little tool here is just not doing it for me right now. And then we can also say if we passed a block. So if we run this, we will not get an error anymore. We call the method that didn't exist twice, read, and then with args and with a block, and we just handled it gracefully. I say gracefully because we intended to handle it here. If you are actually wanting to throw an error, this is not graceful. This is a problem because when you have an actual error, you want to get the actual error. So it looks really cool. Be hesitant to use it unless you have a valid reason, and those do exist. That's actually how active record used to work. It would actually, if you called book.read, for example, and it was an active record model, it would go all the way up the chain and be like, oh, I don't know what read is. Let's hit the method missing function, and let's try to link that up to a database column. If it exists, then we just return that instead. That can be time consuming because it theoretically goes all the way up the ancestor chain, which is just time, it's processing. And if you're not careful, you'll swallow errors that you didn't mean to. That kind of goes to that first thing. What you can do in method missing is you can continue going up the ancestor chain to hit the normal method missing if you call super in there. And again, because we're in a class, we have access to super, and method missing either exists on basic object or object, so it exists at the top of the chain. So let's say you wanted to handle something. Usually what you would do is in method missing, if you knew that you wanted to call a function that looked like this, or you had some parameters for what you wanted to handle, you can handle it, but you would only handle specific cases, and then everything else you would throw it to super here and let the actual method missing throw a no method error. That's a safe way to do it. But again, we're just intercepting states at runtime here, so this fits into the whole metaprogramming and ecosystem. All right, we're done with methods. We're going to talk about closures here, and we're going to talk about scope. In Ruby, there's 3 spots in Ruby where scope will actually shift, and you can't, by default, access scope outside of these areas. In class definitions, in module definitions, and in methods. So what that means, it makes this impossible. We have a variable called myvar out here. We can't use it in my class. We can't use it in my method here. Those are both scope gates. Even if we had a variable if we have a class variable in my class, obviously we can use it there. But if we just had an instance variable just a normal local variable in my class, it's blocked from access here in my method. Those are scope gates. So with metaprogramming, though, we can manipulate scope, bend it to our will. That's the tagline, bending programming to our will. So there's two ways to define a class. The one way you probably are very familiar with, and it's the normal way, which again I'm going to call statically. Ruby is not a statically typed language. It's just the way that lexically makes sense if you think about it from the interpreter standpoint. This is how you normally define things. We've got a book, class, we've got a title in there, we've got The Handmaid's Tale. I read that book. It was very depressing. Good book though, just depressing. Have a nice hot cup of like warming tea when you read that, because it'll chill you. So we just define a book, book.new, and we call .title. Nothing fancy there. This is what we expect. This is pretty standard Ruby stuff. What if I told you there was a fancier, I don't want to say fancier way, a different way to define a class in Ruby that is dynamic, and again, don't take that literally, it's just different from the previous way. This is the more metaprogramming way. And this is where understanding Ruby's object model comes into play, because this is where you get to see some of that. So we can define a constant, a variable called book. It doesn't have to be capitalized. I don't think it does, I should say. I know if you're defining a class the normal way in Ruby, it does, as far as I know. But we're just setting a variable equal to class.new, and this is a block. Well, blocks are not scope gates. We can access things outside of the scope of the block. And inside of here, so we're actually defining a class here, and it might not look like that. It might look like we're defining an object of a class called class, but if you remember, that's what a class is. Like a custom class is an object of class. So this is where that knowledge comes into play. We can define we can define methods both ways in here. We can define them the normal way, which is def, or we can use define method, either one, but that allows us to get outside of scope gates as far as the class level goes. So if we print this out, we get two objects defined the new way. We're accessing both methods, def and define method, and it all works. So this is a way you can define a class if you need to access scope outside of that class. We can define classes this way because all classes are objects and they all have a class of class. That's where that knowledge comes into play. So back to scope, that lets us do something like this. We can access my var here, and inside of this method here, we can this will print out just fine. Inside of here, because we're not invoking a function anymore. We're calling a function. We're not defining one that has a block, and inside of there, we can also use my var. So if I print that out, we get access to this variable across the whole entirety of this class. I want to take a step back for a second. We couldn't access my var in this right here. This is the proper method that Ruby blocks with scope gates. We can't access my var in there no matter what if it's outside of that function. We can here because we're dynamically defining it, and lexically here we do have scope because we don't have a scope gate. We're just using a block right here. Again, that only defines for method declarations, not using a method. So all the fanciness here with just bending scope to our will. So the schemingly scopeless process is called a flat scope. This just means you have access to everything. I don't want to use the word global scope, but you know what we're getting at there. If you want to just modify scope, it's this. Let's talk about closures a little bit. I'm not going to get too deep into this, and this is not tied directly to metaprogramming, but you will see these quite often, and they're not the easiest thing to understand in Ruby. So to get an in-depth explanation, I mentioned this a little bit ago, but I have a YouTube video about a talk I gave earlier at this group about how closures work, really, how blocks, procs, and lambdas work. It's a whole talk for beginners going from the ground up. So if you want to really dig into what these three concepts are and really understand them, I would encourage you to check that out. We're going to do a cursory glance, and we're going to start about midway through here. But almost everything in Ruby is an object. I've said that a couple times now. Well, blocks are not, and they're actually one of the only things I know that are not objects. I think methods themselves are not actual objects either, but those are the only two things that I could think of. But there are two callable structures which are objects that relate to blocks, procs and lambdas. And again, if you've used Ruby, you've probably heard of these before.
All right.
In other programming languages, lambdas are very commonly used, and they actually behave pretty similar in Ruby as you would expect in other languages. We're going to dig into the differences there. And again, it's not 100% related to metaprogramming, but I think this is just a quick thing that is very powerful to understand what the differences actually are. So what a proc does here, basically the ampersand in here, I don't know if I had an explanation about that. The ampersand here will turn a block into a proc or a proc into a block. So right here, we're defining a proc. We're using that ampersand there to turn into a block, and then we can use that in my method here. Yield is how we access blocks in Ruby. So if I print this out here, there we go. In Ruby, functions are not first-class citizens. That's probably a dead giveaway as to that fact that they're not objects. But blocks are not first-class citizens either. And what that means is that you can't set them to a variable, and you can't pass them around as if they were normal arguments. Well, procs and lambdas, you can. They are first-class citizens. So if you ever needed to pass callback-ish logic, you'd have to wrap it up in a proc or a lambda and pass it around. So that's what we did here. We defined a proc, which just prints out Bill. That's just the callback right there. We set it to a block. We didn't have to, but we just converted it to a block to showcase that here. And then we just yielded to the block right here. So that's why we get Bill yields out there, because our proc got turned into a block. Again, I know this may not seem like super easy stuff to understand. Go watch the other talk about closures if you want to get a good understanding about how all this works. So what's the difference between a proc versus a lambda? You can call them both. They're both first-class citizens. Before I go further, does anyone have any guesses as to what the differences are? So the differences are, and it's not super intuitive, there's two differences. Lambdas, which we're going to show a little bit in a second, lambdas will throw an argument error if the argument number doesn't match. Procs do not. That's the easier one to understand. Lambdas return in a local scope, whereas procs return from the scope in which they were called. That's the little bit harder one to understand, and we're not going to dig into that until we get to this example, because it's not super intuitive. So let's say we have a lambda right here, and lambda, we just saw how we could define a proc before. We just swapped that out with lambda, and we've got a lambda now. Again, very similar. The only differences are those two things I just mentioned. If we run this right here, we've got a lambda inside of this function. We've got a lambda that just returns x times y. To call a proc or lambda, we just invoke the call function on them with whatever arguments, 2, 4. So we could theoretically assume that this right here is going to multiply them together. It's going to return 8. We're going to multiply that by 10. We're going to return the results. We can assume that we should get 80 here. So if we do that, bam, we get 80. It's more or less what we expect. Well, with a proc, we get something a little bit different. It's the exact same code. The variable names and function is different, but the only major difference is we change proc out for lambda out for proc here. And when we do that, we get 8. So why do we get 8? Well, the idea here, the core idea, and this goes to the idea of lambdas return in a local scope, which is what you expect the behavior to be. Procs return in the scope in which they were called. That's because lambdas behave like functions. They behave like methods, which is what you expect. That's why they're named lambdas. They're just an anonymous function. Procs, on the other hand, behave more like blocks in Ruby, and blocks have some weirdness to them. They're very core to how the language works, but in a block, if you explicitly return something, it'll return from the scope in which the block was actually called, which is right here, for example. Like, we invoked proc example. It's right here. That's where we actually call the scope. So when we call proc.call here, we're actually returning from the scope right here. So it's just exiting the function right here. As soon as we hit proc.call, it just exits, and we don't do the times 10, and we don't do the return result. It just calls right there, and that's just because that's how blocks work. So my go-to thing here, this is really the end of this closure topic, but scopes usually work how you expect in lambdas and procs, but if you do have an explicit return in your proc, then you might have some issues. I thought I had a recommendation here, but in a nutshell, I would recommend using lambdas if you ever need a callable object. Procs are pretty common in Ruby, and again, they're completely fine. It's just if you have a return statement and an explicit return versus the default way in Ruby to return something is just to not have a return statement. It's just the last line of code. You can if you're exiting early, you can return. That's completely fine. But in procs, there's that little gotcha. So my recommendation is if you need to use a callback logic, use a lambda. They are going to be much more like what you expect. So our last major thing we're going to talk about are evals. Every language has them. It's just the idea that you are evaling code at runtime based on whatever you pass in. It's usually a string. I think it always has to be a string, actually. They're very dangerous, too, and we're getting into that. Ruby has got a couple of different ways to handle evals, though, that are a little bit safer, and it's got the major eval function that you expect, which is eval, but it's got two other ways you can evaluate things that, again, are a little bit safer, still very powerful, and you can still mess things up, but you don't really have to worry about code injection as much there. I take that back. I guess it just depends on your situation. But we're going to talk about instance eval and class eval first before we get to just normal eval. So instance eval, Instance eval, this is a way you can access an object if you need to not only access private variables, you can modify private variables, you can actually just get into an object and do any kind of stuff that you need to do. So here's an example here. We've got a private instance variable, just by default, an instance variable without a getter or a setter in Ruby is private, and that's the @ symbol there. So we're setting it equal to 1. We're creating an object called book.new, and we're saying we have a variable here called x equals 2. We're going to say object.instanceEval, that's that function we're talking about now, and it accepts a block, and we're setting the private variable, the instance variable of our object, v, of our object, we're setting the instance variable v to x, which again, because we're not in a scope gate here, so we can use variables outside of here. We're setting it equal to 2, and then it's still a private variable. We can't just access it even to read it not without having an attribute reader or an attribute accessor in the class here. So to actually read it, we have to do an instance eval again and just return it. So we're actually modifying and reading private variables here, and that works. We just modified a private variable. You don't have to do it for this type of behavior, but if you need to dig into the internals of an object, Ruby gives you the full capabilities of doing that. If you're writing your own code, you probably don't have to do this because you know your situation. You're not going to make something private if you need to access it. But you could if you want to prevent other people from doing it, but you've got the one edge case that you want to account for. But Ruby just gives you the keys to the kingdom, and you just have to know how to use them. So this is instance eval. We're going to talk about class eval, and they're probably what you expect, and it's probably not. So with open classes and dynamic class creation, which we talked about before, we couldn't update a class within another closure, like a method, until now. Here's an example of that. If we were inside of a function, we couldn't just add a method to a class. You might think, why would I ever do that? I'm just telling you, I don't know, but for whatever reason in the past, I've actually done these things, and the capabilities are there. Ruby does not block you from doing this. But you have to you can't just do it the normal way. You have to use class eval like this. So we're inside of a function here, and let's just say you wanted to add a method to some class. So we do class and then class eval. It's the function, it accepts a block, and then we can just define a method in there. This is just an example of how you can define a one-line method in Ruby if you want to. Usually you don't have semicolons, but Ruby will work with semicolons, especially if you want to do one-line type things. So we're just adding a function called, let's see. We're adding a function called m. It just prints out hello, but we're adding it to string. Before this, string didn't have that. So if we run this, that works. So we just, inside of a method, we busted open a class, added a function, and then just exited all of that. So you can do some pretty intense stuff here. There's more you can do with class eval, though. So in Ruby, you can actually access a class without having the constant itself. If I go back a level, we actually passed in string here. This is the actual constant that refers to the string class itself. If we had changed this to a variable, an actual string, that was the word string, which we're going to do next, this wouldn't work. But in Ruby, just with a little bit of modification, you can make that work. So here, it's the same exact code, but instead of passing in the constant for the actual class, we're passing in a variable called string, and using kernel.constget, kernel is a module that object includes, which is why we can access this here, although it's a static function. So we're saying kernel.constget, and then we're passing in the string. This actually will get the class itself, like the class object, the string class object. Boy, that's just a weird thing to say. But and then we can update that class there. We can't, using kernel.constget, we couldn't create a class the normal way. We couldn't use an open class the normal way like we've shown before. We can only access it with class eval here, but this is just showing like we're getting even further down the pipeline. Like we're modifying a class inside of a function, and we're accessing that class just based on a string value here. So literally, I think the key point of this is that if you have any way you want to modify data, like as long as you can represent that data enough to like a variable, you can access anything inside of there. And let's prove that this works. Now, and it works. Now, there's something you're probably thinking, okay, instance eval only works on objects, and class eval only works on classes. And I know you wanted to cling on to something that just makes sense. I'm sorry, but that's not necessarily the case. You can call class eval on an object, because what is a class? A class is an object of class. And you can call instance eval on a class. Again, classes are objects of class, so they're kind of the same thing, objects of classes, at least architecturally. So what's the difference between them? Instance eval only changes self, while class eval changes both self and the current class. That's the major difference there. So instance eval, you can only modify that object's actual stuff. we could actually do the same thing here, instance eval, and I've not tested this, but let's just kind of see. I bet this. No, apparently that did not work either. We had to do class eval here. Class eval actually changes both the object itself, which is the class, and it'll actually update the class itself that you're inside of. I'm not going to dig too deep into that because that's not super imperative for this, but they are different and they're not only related to an object or a class. You can use them a lot of the times interchangeably, but if you are modifying the current class you're in, you'll have to use class eval. Now let's talk about eval, and we're on the home stretch here. Eval is different from instance eval and class eval. This is just plain and simple. It just accepts code and runs it. So if we did this, for example, we've got an array, we've got an element here. Array is an array of 10 and 20, element is just an integer. This is the way in Ruby that you just push something to an array. Boy, I never thought about that, but that's like C stuff right there, like C out and C in. Anyway, if we run that, it works. You know, it just, even though this is an entire string, it evaluates in the scope of the code. It's very similar to how evals work in other languages. This evaluates to the array object, this evaluates to the element object, and this is just the operator that appends element to array. Nothing super fancy there. So here's a deeper example, and let me zoom out of that a little bit. Is that pretty hard to see? Let me see if I can zoom in just a smidge there. So inside here, this is where we can do some really crazy stuff as far as like scope gates go. If you just wanted to, we're defining code here. We've got a here doc, just a multi-line string. We're defining stuff in Ruby how you would normally do it. We're just wrapping it up in a string. Well, if we just wanted to ignore scope gates altogether, even with traditional Ruby code here, we can use eval statements because it's just evaluating the code in line. Like this right here, again, syntax highlighting is a little bit off here, but this is not a comment, this is string interpolation or variable interpolation. So class is the word book right here, so that's getting injected here. So even though it looks funky here, when it gets evaled, it's going to say class book like Ruby normally expects. We've got an attribute accessor here. Again, this looks weird, but we're evaluating it to a string, so before it actually gets run, it'll look right. Where we've got an initialization here, and this works. If I were to zoom down, I need to take away that capture. Anyway, that works right there. So we can just eval to our heart's extent if we need to. I'm going to zoom out here again. So let's get to, benefits of eval, you can just evaluate any code you need to. There's a dark side to it as well, as we can all expect. Let's say that you write a program that you just want to test out all the methods that the array class has. And I'm going to zoom in a little bit here. So you've got a function called explore array. You want to just call whatever method it has on it. So find index C, for example. That's going to ideally print out, I assume, 2 here. And it's going to tell you what it's evaluating. It's going to tell you the code, and it's going to actually eval the code here. Well, when we run that, that's going to be fine. So yeah, it says evaluating that, and then it evaluates to 2. Well, let's just say we have this line here. We are just evaluating object ID, which is just, that's a field that everything in Ruby has, the object itself. And we do semicolon dir.glob star. Let's see what that does. Well, that gets evaluated, and this is the actual directory that I'm running this presentation from. That probably gives you an idea of what the presentation is. But this is like stuff that you shouldn't be able to do. This is accessing server information. We can do much more intense stuff with this. So eval gives you some pretty intense capabilities that you definitely want to make sure you're sanitizing things. It's like SQL injection. That's what SQL injection is. You're just running an eval statement, more or less. You need to sanitize your stuff. So no matter your stance on vaccinations, we can all agree that code injection is bad. And this is the last major slide. Another, kind of like the closures bit, there's a lot of things about modules are not super well understood in Ruby. And I just wanted to give a little example here about a pretty good approach to creating a multi-purpose module. Multi-purpose meaning modules in Ruby are usually used to add instance methods to a class, but you can also add static methods to a class as well. And this is kind of a good standard way to do that. So we've got a class here, and we're just including my module, and that's the module up here. Well, every module has got this function. It's a static function, because modules are still classes in Ruby, which are still objects. Brain explosion. But it's got this included static function here, and base is the actual class that you're including it in. This is a lifecycle method. So anytime that this include function gets called, this will get fired on the module. So what we're doing here is we're saying we want to base, again, is the class that we're including the module on, so base is going to be my class here. We're going to say base.include instance methods, which is a module right here, which that's the exact same type of include that we're doing right here. So we're basically saying include these modules right here as instance methods, but then we can extend the class itself with class methods, which is right here. So for example, if we do this, we can say puts myClass.classTest, that's a class method, it'll work. MyClass.new.instanceTest, that will also work here. And the part that I think is often misunderstood is it's common to think that include by default only works for instance methods and extend only works for class methods. And that's not true. The include part is correct. Including will include things as instance methods. However, extend does not include things as class methods per se. It extends the capabilities of whatever your self is, which is the base right here, with those functions. So when we're calling include right here, the scope is actually in a class level scope. So when we call extend, we're extending that class scope with these functions right here. You can actually call extend on an object itself. Again, classes are objects, I know, but the normal objects you would think of, you can call extend on that, and that will just add another instance method of that object, even though you're using extend. So don't always think that extend is a class versus instance method level thing. They're a little bit different. Yes, question by John?
So if you extend on an instance of a class, that's the same thing as basically doing include on that class?
Yeah, that's correct. So the question was, if you extend in, let's see, an instance of a class, so like what we've got right here, myClass.new, it's the same thing as including the module for the class itself. I should say that is true with a caveat that when you extend a single object, that only applies to that object. It doesn't apply to any other objects that you've instantiated of that class. So it's kind of it becomes really a singleton object at that point, which singleton objects are something that definitely fits into metaprogramming with Ruby as well, and then you get into eigenvalues and eigenfunctions. There's some really good books on that. We're not digging into that here. I've dug into that years ago, and I never really found much value in it, and if you think this is complex, it gets deeper. I'm sorry. But I know we went through a huge whirlwind of stuff here. In a nutshell is that Ruby allows you to do like anything as far as messing with your current environment. And again, this is not really to encourage you to go out and change all your code to work like this, because I probably should not recommend that at all, because again, like as I've gotten older with coding, I think code readability is probably the most important thing you can do, and metaprogramming usually jacks with that a lot. It's not super easy. If someone was not only an expert at Ruby looking at this, but someone new to Ruby, that becomes a problem if you were the only one who can really understand the code. So use it when it makes sense. I don't think there's ever a point in time where you really have to say you need metaprogramming. I just think it's a tool in your toolbox, which if you need to dynamically call a method, that's probably the most common reason I use metaprogramming. I think it makes sense in various situations to do it. Just you have to be the one to define what makes sense and what doesn't. So that's all I got. I am the code boss on all the social medias. That's my GitHub, Krauss48. I created that before I thought of the code boss handle, and some other person who is the other code boss, well, he got the GitHub handle, but I've got the codeboss.dev, and he's also a developer. So I think I'm winning at this point. So that is all I got. Yeah, anyone have any questions?
Could you pull up that example earlier?
Yeah. Let's see, so I figured I'd logged in before with this computer. I know I have. Make sure that in the meantime, because I've done this before. Anyway, just in case anyone was wondering what tool I'm using, I usually use a pretty silly tool called Cent, which is just super lame. This one is not that. This is actually just an IPython notebook, like a Jupyter notebook. So that's why I was able to run code. And that's all this is. Pretty bomb. Now if I can remember where that example, actually, here we go. Wait for it. Okay. No, it's the YouTube video. Dang it. Okay, this goes back a little bit further too, I think. Wait for it. I probably could just look at the Jupyter notebook, and it'd probably be a lot quicker than this. But this, did someone find it? Oh yeah, good job everybody. Okay, so I wrote this a while ago, back in my hardcore Ruby days, but this right here is what I was getting at. This is this is just a tool that wrapped around a library called HTTParty, which is one of the common HTTP libraries in Ruby. And this is what I was going to point out here. So here, we're just, HTTParty has functions called get, put, post, delete, and I just wanted to wrap around that, like add some additional functions, set headers, etc. So right here, I just defined an array of, again, this is just an array of strings. You don't have to define arrays like this. It's just a little shortcut in Ruby. Again, you want to learn more about these little shortcuts, look at Austin's talk on YouTube. But we're just iterating through those. We're calling define method here of the request types. We're defining methods called get, post, put, and delete. Putting a block in there. URL is, request type is the method accepts a block, and then optional options as well in that block. And then we're just doing the logic here. So in a nutshell, this just defines 4 functions that all behave very similarly. The only difference is that we actually, let's see where we're using request type. So or URL here. We're using request type. So we use that down here. Okay, so self.class.send, that was a way for me to access HTTParty's actual function, like put, delete, post, etc. And then this just defines an open struct, which is kind of like a really fancy hash in Ruby, hash being the key value pair that Ruby uses. PHP's got associative arrays, JavaScript's got objects. Every language has their own different way of calling that data structure. But this is where I actually use this. Now, it's funny, I've given this talk before, like 4 or 5 years or so ago, and someone there is a very talented Ruby developer. He mentioned that he was giving a talk at a conference about why you shouldn't use metaprogramming. So just to show you that ecosystem is I don't want to say it's I don't know, not one side versus the other, but there's opinions for sure. He mentioned, like, could I just create a function called request that accepted this, either one of these as a function parameter, and then I could just do the same thing. And I could do that. You could do that. You don't have to do this. This is just a way of actually defining a function called Ruby, or called get, post, put, and delete, versus just handling it as if you were passing in an argument that way. So Ruby is awesome because there's just hundreds of different ways to do like the exact same thing. Kind of like CSS, but actually good. So that is all I have got. Thank you for calling that out. If you want to learn more about blocks, I got a YouTube video about that. Austin's got a good YouTube video about the Ruby shorthand notation tools. And that is all I got. So, all right. Thanks, everyone.